Good day, class. I hope you guys are doing well. Today we are starting our class on negative binomial distribution. Welcome to Statistics and Mathematics YouTube channel. Please, if you haven't subscribed, kindly subscribe, like, and share so that this video will get to your friends and then they too can watch, right? So our negative binomial distribution is a discrete probability distribution that model the number of failures before achieving a fixed number of successes in a sequence of independent Bernoulli trials, each with the same probability of success P, right? So at the end of the day, we could see that when you compare the negative binomial distribution to the geometric distribution, we see that for the geometric distribution, it's used to model the number of failures before we can achieve our first success, right? But for the negative binomial distribution, it's used to model the number of failures before you achieve a fixed number of success. And then each trials are independent on each other, right? So one trial does not depend on the other trials, right? But before one can be able to solve any problem with any problem of negative binomial distribution, he or she has to be able to understand the PMF of the negative binomial distribution. So when we come here, we are saying that we are having about 3 or 4 parameters in our PMF. So I would like us to go through the parameters before we will explain the PMF itself. So our R is the number of success success waiting to achieve. That's our R. And then P, the probability of success, as you know. And our X is the number of failures before our success is being achieved, right? So at the end of the day, you could see that our PMF is written as K plus R minus 1 combination R minus 1. So we see when we are really giving something like that without any when we are giving this without any division sign here, right? When you are giving without any division sign here, most of the time it's used to represent what combination. So here we are having K plus R minus 1 combination R minus 1, right? Times P raised to the power R times 1 minus P raised to the power K, right? So at the end of the day, this is how things work out here, right? So this is the PMF, right? Right now we know our K, we know our R, right? And we know our P, right? Inside this our PMF, right? So this is how the PMF look like. And then we have the mean, variance, and standard deviation. So the mean for the distribution is R bracket open 1 minus P, right, divided by P. And then the standard deviation too is R bracket open 1 minus P divided by P squared, right? So this is the standard deviation, this is the variance, right? So once you square root the variance, right? So if you have SD, once you square root the variance, right, we are surely getting what our SD, that's the standard deviation, right? So once you square root the variance, we get what our SD, right? So let's go to our worksheet so that we can work an example out. So this example 1 that I would like to take you guys through. Please give me a minute so that I'll clean what we have here, then we can work something out. So we are having this question. It's saying that a telemarketer makes repeated calls, right? Make a repeated calls to persons on computer generated list. The probability of making a sales on any individual call is P is equal to 0.10. Successive calls are independent. What is the probability of making exactly 5 unsuccessful calls before the third sales is made, right? So at the end of the day, let's firstly write our PMF down, right? So we are having a PMF of P of X, which is equal to K, right? Is equal to K plus R minus 1 combination R minus 1 P raised to the power R, right? K raised to the power Q raised to the power K, right? So this is what we have, right? This is what we have. So at the end of the day, you could see clearly that we are supposed to get our K, our R, our P, and Q from the question, right? You are supposed to get these things from the question, right? So let's find out our P, right? Our P is simply 0.10. Here is our P, and then our Q is giving us 1 minus 0.1, which is 0.9, right? And then our our R, right? Inside the question, our R is what? The success, the number of our success that can appear. And then when we read the question, it said, what is the probability of making exactly 5 unsuccessful calls before the third sales is made, right? So the third sales is made means that it's successful, right? So at the end of the day, here is what? Our R is 3. And then you see, we are supposed to find for our X, but we have used our X to represent what? Our K. And we are saying that our X is the number of the number of failures until we can achieve a number of success, right? So the number of failures here is what? 5, since we are having 5 unsuccessful calls, right? So here our K2 is giving us what? 5. So right now we have our P to be equal to 0.1. We have our Q to be equal to 0.9. We have our R to be equal to 3, and then we have our K to be equal to what? 5, right? So we have 0.1, 0.9, R, and what? 5. So we are going to just substitute this one inside this preamble. So wherever we see K, we are going to substitute 5, R to be 3, P will give us 0.1, and then Q will also give us 0.9. So that's the same thing you see the slide is just showing us here, right? So that one will be 5 plus 3 minus 1, combination 3 minus 1, times 0.9 raised to the power 5, that's the K, right? Times 0.1 raised to the power 3, was times 0.5 raised to the power 3, was our R is equal to what? 3, right? So at the end of the day, once you have this one and then punch it, simplify. 5 plus 8 is 5 plus 3 is going to give us 8, minus 1 is giving us 7, 3 minus 1 is going to give us 2. Once you simplify, this is what you are going to get. Then punch it on the calculator, you get 0.0124, right? So this is how the negative binomial distribution also works out. So we are bringing the discrete probability distribution to an end, right? So in our next video, we are going to work on the continuous distribution, and then we are going to tackle normal distribution. Thank you, and then see you there. Bye.